Okay, so we're looking at mixed trig word problems. Draw a picture for each problem and label the parts you know. Usine, cosine, tangent, arc sine, arc cosine, and arc tangent. We've got to talk about these. Arc sine is the same as, if I say arc sine of x is the same as inverse sine of your x. Okay. Arc cosine of some value x is the same as inverse value of x, and arc tangent of x is equal to the inverse value of x. So I want to make sure you're aware of that. They're synonymous. It's just that they do that for to facilitate lack of confusion, but if I didn't show it to you, there's more confusion. So that's what those mean. Now, suppose you have been assigned to measure the height of a local water tower. Climbing makes you dizzy, and so you decide to do the whole job at ground level from a point 47.3 meters. So I've got my water tower. Okay, my water tower and my trees kind of look the same, so just we'll deal with it. This is a really nice strong base for my water tower. I'm at a point. We want to find out the height of my water tower, and I'm at a point. 47.3 meters, that's 47.3 meters. Maybe perhaps let's do this. Let's undo that and that. Okay, so I'm going to go to 47.3 meters and we'll do it this way. I'm going to box these up, group them, and go 47.3. Now, so I'm 47.3 meters away. And you find that you must look up at an angle of 53 degrees to see the top of the tower. How tall the tower? This is 53 degrees. Now here's the thing. We're assuming that the angle is in with the ground here because I wasn't told any information about the height of the observer or their eyes. So I want to find x, which, well, h here, the height. So when I'm doing this, I'm standing on 53, h is opposite, 47.3 is adjacent, so I've got tangent of 53 degrees is equal to h over 47.3. So 47.3 times tangent of 453 is what I'm going to be able to solve this in, and I grab my calculator. Okay, make sure my mode is in degree, and it is, and so I second quit, and I'm going to go 47.3 times tangent of 53, and this is in degrees, close, and hit enter. So I got 62.76, and according to this, so my h is 62.8, because they want me to look up and find how tall is the water tower. Okay, it doesn't say anything, and working from point, meters, base, water, you find. Okay, and we're really happy. 62.8. So my water tower is 62.8 feet tall. Now, in problem 2 here, you lean a ladder 9.6 meters high against the wall. It makes an angle of 63 degrees with the level ground. So this is my wall, this is my ladder. Okay, ladders are always the hypotenuse. Okay, the ladder is 6.7 meters long. The angle with the ground, it makes an angle 63 degrees with the ground, so that's 63 degrees. Okay, how high up is the top of the ladder? So we want to find out h, my height there. Now, I stand on 63, I'm opposite hypotenuse. So I have sine of 63 is equal to h over 6.7. So 6.7 sine of 63 is the height, or the height up the wall my ladder is going to be. And again, I grab my calculator and I go 6.7 times sine of 63. And I find that my ladder is reaching 5.969 up as far as feet. Now we're asked here, how high is the top of the ladder? Well, if I do it to the nearest tenth, I'm rounding and I get to 6. So my ladder ladder reaches 6.0 feet high on the wall. Okay. Now your cat is trapped. Sorry, your cat is trapped on a tree branch 6.5 meters above the ground. Your ladder is only 6.7 meters long. If you place the ladder's tip on a branch, what angle would the ladder make with the ground? So you're going to be a daredevil to save your cat. Let's get Kitty here. We got Kitty. This is Kitty. This is Kitty's body. This is Kitty's tail. This is Kitty on the tree branch, and this is your ladder. Okay, your ladder is 6.7 meters, and apparently you know exactly how tall that tree branch is. That's 6.5 meters high. Okay, so now you want to find out this angle. So what is my angle that Kitty is sitting on? What angle do I have to have my ladder at to make it work? So I'm looking at an inverse value to find an angle. So I've got opposite hypotenuse, which would be sine. So I've got the inverse sine of my ratio, 6.5 opposite over hypotenuse, 6.7. And again, I'll put this in my calculator. Okay, so second inverse, so I have my inverse, 6.5 divided by 6.7. Okay, and I'll close that out and I'll find that I'm at 75.96 degrees. Well, I'll round that to 76 or 75.96 and I'll round it to 76 degrees total. So 76.0 degrees is the angle the ladder makes with the ground. Now, in our next one, we'll move this stuff around here. I'll slide that up. Maybe. A submarine is at the surface of the ocean, makes an emergency dive. So we're at the surface of the ocean. Our sub makes an emergency dive. Okay. Now, its path making an angle of 21 degrees. So this is 21 degrees. Okay, with the surface. And our sub's going along here. Okay, that's our sub. If it goes down to 300 meters along that thing, so this is going to go 300 meters. Okay, so it travels 300 meters along here. I wonder if I can pull my sub. Oh, look, I can pull my sub. Now, this is like planning beyond belief. Okay, if my sub's right there, okay, it's gone 300 meters down downward path. How deep will it be? And what horizontal distance is it from the starting point when it gets there? So we're going to freeze this in time, and I have a depth. And we're going to freeze that in time, and I have a horizontal distance along the surface that my sub has, we're asking about for my sub to travel. So how far along the surface did it go? What's the horizontal distance? What's the depth distance? So we got two things to find. So let's work with depth first. I'm going to slide this over and bring my little sub friend with me. Okay. So I'm going to find depth first because that's what we are asked to find. First, so I'm from 21, deep and 300 is hypotenuse, so it's opposite hypotenuse, so it's sine. So I've got the sine of 21 degrees is equal to deep over 300. So I've got 300 sine of 21. So we should be looking at that 300 sine of 21. And I have 107.5 feet deep. Okay, so this is 107.5. Let's double check. Oops. Second recall. Enter. 107.51 feet deep. Okay, feet. Now, if it goes down, how deep will it be? 107.51 feet deep. Okay, and maybe what we ought to do is do this, and we'll say that that is blue. Okay, now, let's make that all blue, by the way. Hey, look, it's all blue. That's how deep we are in the deep blue sea. Now, let's look at see what's happening for our horizontal distance. Our horizontal distance from 21 is adjacent, and our hypotenuse is still our hypotenuse of 300, so adjacent hypotenuse cosine. So I have the cosine of 21 degrees is equal to h over 300. So now I've got 300 cosine of 21 is equal to h. So I take that 300 cosine of 21, oops, close that, and I got 280.07. So this is 280.07 feet, which equals my horizontal distance. Okay, so that's how far the sub traveled horizontally. I'll get that stuff moved up so I can have room for my other problem here. Now, this next problem, number 5. An escalator at a shopping center. Okay, so I've got an escalator. Okay, roughly like that. You know, you get on, you hold the thing and go up. It's 200 feet 9 inches long, which is 200.75 feet long, because 9 divided by 12 is equal to 0.9. And where did I get that? 9 inches divided by 12 inches is 0.9 feet. Okay, so, excuse me, 0.75 feet. Okay, and that's why I was able to go 200.75 feet. Now, it rises at an angle of, and for lack of a better purpose, we have a triangle. It rises as an angle of 15 degrees. What is the vertical rise of the escalator? What's the vert rise? Okay, round your nearest inch. So I got 15 opposite hypotenuse. Opposite hypotenuse is sine. So I've got the sine of 15 degrees, okay, is equal to V over 200.75. So 200.75 times sine of 15 is equal to V. So I pop that in my calculator, and I've got 200.75. And let's slide my calculator over a little bit. Sine of 15. We'll bring it over this way. So I've got times sine, well, I got 75, sine of 15. So that's 51.9579. Well, let's see what it is. It's 51 feet, but 0.957 minus 51 times 12 is 11.495. So, you know, it's supposed to round to the nearest inch, and the nearest inch would be 51 feet 11 inches, the way this is written. So this becomes 51, excuse me, I got to get my calculator back up here, kind of. So I've got 51.957, okay, and that is my V. And now I've got, that's 51 feet 11 inches, okay, because that's going to be 11.49. You just saw that, so it'll be 51 feet 11 inches. Or if I really wanted to go crazy, that would have been 51 times 12 plus 11, which would have been 623 inches. All right, so now sliding on, we are looking at our next page. Number 6, a straight ramp rises at an angle of 25.5 degrees. This is 25.5 degrees. And it has a base of 30 feet long. My base is 30 feet. How high is the ramp? And they want to know how high the ramp is. So this is opposite adjacent, so I've got tangent of 25.5, which equals h over 30. So I got 30 tangent of 25.5. Now we bring up our calculator, and I've got 30 tangent of 25.5. Close it, hit enter, and I got 14.309. So I got 14 14.3 feet is the height, and then went the nearest foot. So the ramp is about 14 feet high. Okay, and number 7, the lengths of the diagonals of a rhombus are 4 and 7. Now you got to know some things about rhombuses. First of all, the diagonals here go up here, and this is 7. And I want to be clear about this, so let's see if I can recognize shape. Well, I don't think I can do that, but let's clone this. We'll clone that, and so you guys will have an idea of what I'm doing. This is 4, so this is 4. Okay, now in a rhombus, the diagonals bisect each other. So really what it is half of 7 is 3.5, half of 4 is 2. And folks are like, well, what do you mean by half? And if I blow this up, I'm going to do this in blue, and I've got this triangle. Okay, so we're going to pull this triangle over, and this is a right triangle. This is a right angle, and this was supposed to be 2, because that's half of 4, and this is 3.5, because that's half of 7. So really what we're doing here is we're finding the angles. So if I find this angle, which is going to jam with this angle, and if I find this angle, which is going to be connected to that angle, I double those two angles and I find the measure of the angles of my rhombus. So now I'm finding angles. So to find that red angle, I'm going to go opposite adjacent, which is tangent, inverse of 2 over 3.5. To find that, I'm here, second, 2 over 3.5. So I got 29.74. Now, doubling that, because I don't want to do that, I got 29.745. 29.745. I think it was 29. Let's double check. Yeah, times 2. I get 59.48. And they say to the nearest, around your answers, to the nearest tenth on this. Triangle, where is it? Oh, round my answer to the nearest degree. So my nearest degree here would be 59 degrees. So red, if I double that, that's 59 degrees. 59 degrees. Okay. Now, my other side is my green. And from green, I go opposite. So it's the inverse tangent of 3.5 over 2. Okay, so I got 3.5 over 2. So the inverse tangent, second. Okay, let's do that again. We're here. We made a mistake on the calculator. We're going to clear that. We're talking about the inverse tangent, and it's got to be 3.5. 3.5 divided by 2, and that is going to give us 60. And so that's 60 degrees. 60 degrees. And so I have 120 here. So that's 120. That's 60 point what? That's going to be 6.25 times 2 is 121, actually. So that's 121. So that's 121. Okay. So now that'll add up to 360 total for the two. So those are my two angles. Find the measures of the angles of the rhombus to the nearest degree. It's 59, two 59s, and two 121s. So I got 59, 121, 59, and 121 for my rhombuses. These are my 121s, and these are my 59s. Okay, so now a right triangle has a hypotenuse of length 10 and one leg of length 7. Hypotenuse of length 10 and one leg of length 7. Length 10, one leg of length 7. Find the length of the other leg and the measure of the acute angles in the triangle. Find your answers to the nearest tenth. This is called solving a right triangle. We're finding missing pieces. So I'm going to find x, and we'll call this A, B, and C. So I'm going to find the value of x by using Pythagorean theorem. So I've got 10 squared, I've got a squared plus b squared equals c squared. C is actually 10, so that's 10 squared. And then b is going to be x squared, and 7 is a squared. So that's 49 plus x squared is equal to 100. So x is equal to the square root of 51. So I've got the square root of 51, and let's draw that out a little bit clearer. Square root of 51. So this is square root of 51. And they say round your answers to the nearest tenth. So I can put that in my calculator and say that's square root of 51. And what I did, I went 100 minus 49. That was 51. And now I'm going to raise that to the 0.5 power, which is the same as second square root of 51. Okay, so it's 7.14. Okay, so this is 7.14. Round your answers nearest tenth, so 7.1. Okay, so that's a leg. Now I got to find the angles. And because I'm finding angles, I'm going to work with the values that was originally given. So I'm going to start with the angle B. So finding angle B, the measure of angle B, if I'm standing on B, that's adjacent to hypotenuse, so it's inverse cosine of 7/10. And then the measure of angle A is going to be the inverse sine of 7/10. And those are the two values we're going to find. So I've got the inverse sine, or inverse cosine first. So second inverse cosine of 7 divided by 10. That's adjacent to hypotenuse. Okay, which is 45.6. Okay, now I'm going to do the inverse sine of 7/10. That's 44.4. And those two will add up to 90 degrees, and we have it done. So those are my angles. Okay, two values. This is my measure of angle A, and this is my measure of angle B. And again, this is solving a right triangle. Now I've got 3 left. A right triangle has the angle of measure 28. Has an angle measure. So this is 28, and this is 90. The leg opposite 28 angle measures 13. Find the length of the other leg and the hypotenuse. So we're supposed to find this other leg, and the hypotenuse we'll call C. Okay, so from there, round our answers to the nearest tenth. So reread, a right triangle has an angle that measures 28 degrees. The leg opposite the 28 degree angle is 13. So we got opposite, adjacent, so 28. Opposite adjacent is tangent of 28. And that's 13 over x. So x is equal to 13 over tan of 28. So it's 13 over tan of 28. It's 24.4. Okay, so I'm looking at 24.4 for my x. Now, for C, the value of C is going to be opposite hypotenuse, so sine of 28 is equal to my opposite over hypotenuse, so C is equal to 13 over the sine of 28. We'll do that again. 13 divided by sine of 28. And that gives me 27.7. Now, the last thing I was supposed to do is find the angle value. I could have done that first. And the two acute angles in a right triangle are 90 degrees together. So maybe you did that first, and I'm going to squinch those together and talk about that. 90 minus 28, which is going to equal 62 degrees. And that is the measure of the angle right there. Now I've got two left. A rope attached to a tent. Now keep in mind, a rope attached to a tent. Generally you have a pup tent and you have a little pole right in there, and that's your tent. And then you have a rope out here to hold it up. That's that rope attached to the tent. But what this information they're asking about, let's do the sideways of our tent. So our tent is sideways, and I'm going to try to show it this way. And I've got that support pole coming down here. And I have a rope coming out from that support to there to a stake in the ground. How far away along the ground, let's use blue for our ground today, how far away along the ground is our stake located? And let's make our stake a little bit higher there, and we'll clean that up. So there. Everything's all nice and clean. So now I'm looking for that blue, and I know a few things. The rope is 4.5 feet long. This is 4.5. Okay. The angle formed by the rope and the ground is 46 degrees. Well, they're telling me this angle is 46 degrees. Okay. Now, how far from the center of the base of the tent is the rope staked? So that's what they're asking. I'm finding X, the blue. Okay, so how far away is it staked? So I want to know this value of X. So that's adjacent hypotenuse. Adjacent hypotenuse is cosine. So cosine of 46 is equal to adjacent over hypotenuse, 4.5. 4.5 cosine of 46. And I just go ahead and grab my calculator. I got 4.5 cosine of 46. And I got 3.125, which is rounded to the nearest tenth of a foot, 3.1. 3.1 feet away. Okay, now my last one. Jed is building a roof on his shed. Okay, Jed's got a shed, he's building a roof. Okay, he's got a shed, he's building a roof. Okay, this is my intense shed that Jed is building. Okay, the highest point of the roof is 3 feet higher than the top of the shed. So this is 3 feet higher than the top of the shed. The slanted roof will be 7 feet long. This part is 7 feet long. Okay, what is the measure of the angle formed by the top of the shed in the slanted roof? The measure of the angle formed by the top of the shed in the slanted roof. So I'm looking for that angle. So I'm here at this angle, and 3 is opposite, 7 is hypotenuse. So inverse sine of 3 over 7 is my angle we're looking for. Okay, and I pop that in my calculator. So I got the inverse sine of 3 divided by 7. And I get 25.37. And they want the measure of the angle by form. So I'm just going to give you out to the 10th, 25.4. So its angle is 25.4 degrees. That's the measure of the angle formed by the top of the shed and the slanted roof.